Hey everyone! Let's break down linearity in our F-power amplifiers, why it matters, how we measure it, and how to estimate it from a real-world gain curve, also known as an MM transfer curve. In our F systems, linearity means the amplifier's output signal is a clean, scaled version of the input. No distortion, no compression. Mathematically, output voltage Vout equals gain G times input voltage Vin, where G is the gain, ideally a constant. But in reality, as the input power increases, the amplifier starts to saturate. The gain isn't constant anymore, and the output curve begins to bend. This is where nonlinearity kicks in. An MM curve plots output power versus input power. Initially, it's a straight line, the linear region. But eventually, the gain compresses, the curve flattens. This brings us to the key point, the 1 decibel compression point, or P1 dB. How do we find P1 dB? Fit a straight line to the low power, linear portion of the MM curve. Follow that line upward and locate the point where the actual output is 1 decibel below it. That output power is P1 dB, the threshold where gain starts to fall. Why does this matter? When amplifiers become nonlinear, they generate distortion, like intermodulation products that corrupt your signal. To quantify this, we use the third-order intercept point, or IP3. Imagine two close frequencies entering the amp. Due to nonlinearity, unwanted signals appear at 2F1, F2, and 2F2 interfering with your main channel. How do we estimate IP from the MM curve? A quick method. IP3 approximately equals P1 dB plus 10 to 15 dB. For better accuracy, plot both the fundamental slope equals 1 and the third-order IMD slope equals 3. Lines on a log-log plot. Where they intersect is the output IP30 IP3. Subtract small signal gain to get input IP. Want even more precision? Use a polynomial fit to model the MM curve. 5 out equals AVN plus AVN cubed plus ... From this, you can derive both gain compression and IP mathematically. Summary checklist. Fit the linear gain curve get small signal gain. Find where output drops 1 decibel, becomes that's PJdB. Use PJdB plus 10 to 15 decibels, becomes estimate IP3. Fit a cubic model and get precise P1 dB and IP3. Bottom line. P1 decibel tells you when distortion starts. IP3 tells you how bad it can get. Understanding these helps engineers design better, cleaner RF systems.